Reynolds number. Reynolds number is the ratio of inertial forces. Reynolds number is the ratio of inertial forces to viscous forces within a fluid which is subjected to a relative internal movement due to different fluid velocities. Reynolds number is the ratio of inertial forces to viscous force within a fluid which is subjected to a relative internal movement due to different fluid velocities. Hence, Reynolds number which is a pure number comma is given by nr is the ratio of inertial forces and the viscous drag or viscous forces. nr equal the ratio of inertial forces and the viscous forces. nr equal inertial forces which cause fluid to move divided by viscous forces which is frictional force, which are actually viscous forces which are a frictional force due to fluid viscosity. Hence, nr means Reynolds number is the ratio of inertial forces and viscous forces acting in different layers of liquid or fluid. nr means Reynolds number equal inertial forces divided by viscous forces. Here inertial forces cause the fluid to move, and due to inertial forces fluid moves in forward direction, and viscous forces is a frictional force or frictional forces. Reynolds number also determines the nature of flow of fluid or liquid. Reynolds number also determines the nature of flow of fluid or liquid through a pipe. According to Osborne Reynolds, British physicist, the flow of fluid or liquid will be laminar, that is streamline. The flow of fluid or liquid will be laminar or streamline if the viscous forces are dominant, and the flow is characterized by smooth and constant fluid motion. Also, we know the expression of nr, which is equal to Fi by Fv, where Fi is the internal force and Fv is the viscous force, where Fi is the inertial force and Fv is the viscous drag or viscous force. As the viscous force, that means Fv dominates, as the viscous force Fv dominates, that is, Fv is large, so Reynolds number nr will be small. Hence, Reynolds number, not only Reynolds number nr will have low value will have low value for a laminar flow, of fluid or liquid. So this is the picture of Osborne Reynolds, who was a British physicist. According to Osborne Reynolds, turbulent flow occurs at high Reynolds number, or for the high value of Reynolds number, and is dominated by inertial force, is dominated by the inertial forces, which tend to produce chaotic eddies, vortices, and other instabilities and other flow instabilities. This turbulent flow is dominated by inertial forces, and in this case Reynolds number nr is equal to inertial forces divided by viscous forces. Here Reynolds number nr is high or will be high if inertial force Fi dominates over viscous force, over the viscous drag or viscous forces Fv. Inertial force dominate over the viscous forces Fv. As Fi much greater than Fv, Reynolds number nr will be high. Fi is the inertial forces which create eddies and vortices, etc., in the turbulent flow of fluid or liquid. If the value of Reynolds number lies between 0 to 2000, that is, if 0 less than nr less than equal to 2000, comma, the flow of liquid or fluid will be streamline or laminar. If Reynolds number nr greater than equal 3000, the flow of liquid will be turbulent. For the values of Reynolds number nr between 2000 to 3000, the liquid flow, we make a correction. In place of streamline, we can write streamline in the first paragraph. Now the liquid flow is unstable, changing from streamline or laminar to turbulent. If nr lies between 0 to 2000, the flow of liquid will be streamline or laminar. If nr is greater than equal 3000, the flow of liquid will be turbulent. For the values of nr between 2000 to 3000, the liquid flow will be unstable, changing from streamline or laminar to turbulent. Another point in connection with Reynolds number is, we can draw this diagram which indicates the value of Reynolds number. We make a range within which flow of liquid will be unstable, changing from streamline or turbulent to streamline or laminar to turbulent. This is the range or unstable range. And this arrow indicates the increasing value of Reynolds number. Reynolds number increases towards right. For small value of Reynolds number, in this range, the Reynolds number is small and the fluid flow or liquid flow will be laminar. This is laminar flow, and this range indicates turbulent flow. This range indicates turbulent flow. And between laminar flow and turbulent flow, this range indicates the unstable state, changing from streamline to turbulent. This is transitional flow in which the flow is changing from streamline or laminar to turbulent. In laminar flow, viscous force dominates and the viscous force dominates and it tries to keep the liquid flow in the form of different layers. It tries to keep the flow in the form of different layers, or layers of different speeds or velocities, velocities of liquid. So in this range of laminar flow, viscous force Fv is much greater than inertial force Fi, and also Reynolds number Nr is Fi by Fv. As a Fv dominates, Reynolds number Nr will have small value. Similarly, in turbulent flow, inertial force dominates. Inertial force Fi dominates, and it tries to create eddies, vortices, etc. In turbulent flow of liquid or fluid. So in this turbulent flow, inertial force Fi is much greater than viscous force Fv. Fi much greater than Fv, and the value of Reynolds number Nr, that is the value of Reynolds number, will be high Fi is much greater than Fv. High. Now we can consider a tube through which liquid is flowing and maintaining steady flow, or liquid flow will be laminar. That means liquid flows in the form of different layers. We can denote different layers of liquid or fluid which are flowing through the pipe. This is what different layers of liquid or fluid in steady flow or laminar flow. This is streamline flow or laminar flow. Through a pipe, and liquid flows towards right through the pipe, and we can denote the radius R. R is the radius of the pipe, and D is equal to twice of R, 2R, which is the diameter of the pipe. According to Reynolds, British physicist, the critical velocity of a liquid or fluid flow, flowing through a pipe is given by Vc equal Nr into eta divided by rho capital D, where Vc is equal Nr eta divided by rho D, where rho is the density of liquid. Eta is the coefficient of viscosity of the liquid. Hence, we get the expression of Reynolds number Nr, which is Nr equal Vc rho D divided by eta. Nr equal Vc rho D divided by eta, which is the expression of Reynolds number. Vc rho D divided by eta, where Vc is the critical velocity, rho is the density, D is the diameter of the pipe. And also, Nr is the ratio of inertial forces and viscous forces. Nr is equal Fi by Fv. So Reynolds number has two mathematical expression. First expression, Nr is equal to Vc rho D divided by eta, where Vc is the critical velocity, rho is the density, and D is the diameter of the pipe. And also Reynolds number is a dimensionless constant. Reynolds number is a dimensionless constant.